Okay, welcome back everybody. We're going to start looking at our systems of equations unit. Tacks on to basically systems of equations from Math 10. We take it a little step further where we don't only deal with linear systems anymore. So before we do that, we should probably talk about what a system is again. Now, a system is going to be two or more equations that involve common variables. Variables plural. So equations that, as long as they use x and y, are usually going to be your most common. As long as you have a bunch of equations that use those same variables, we say those equations form a system. Now, the solution of a system, what it represents, now we did this in Math 10 when we talked about linear systems, and you saw that those lines, that system could intersect each other. So those lines could cross. So the solution of a system represents the point. I want to put it could either be point or points, because you're going to see here that we could have more than one. So the solution represents the point or points of intersection. Okay, so essentially where the lines in the system cross. So if I've got two lines in the system, they should cross at most once. If I've got something that's no longer linear, like a quadratic, that parabola shape, I could potentially have two. And as you get into higher degree equations, you could potentially have more than that. So we're going to take a look at linear systems first, just to remember what it is we did with those. So we're going to solve the following systems graphically, algebraically, one with substitution, one with elimination. So these two methods you would have learned before. Now we're going to solve the first one using, let's do substitution here. And the second one we'll solve with elimination. Okay, and then we'll show you how to put it in your graphing calculators. So substitution for the first one. Now the way substitution works, now what I like to do is number the equations 1 and 2. It makes it a little easier to know which one we're talking about. Now for substitution, you want to pick one of those equations and solve for one of the variables. Now the easiest choice is to pick one that doesn't have a coefficient in front of it. So I'm not going to choose to solve for x from the first equation, because if I try to divide everything by 2, 3 over 2 won't give me a nice round number to deal with. So we're going to avoid that. So I'm going to pick equation 2, and I'm going to just choose to solve for x. You could solve for y as well. The steps that we're going to do might look different if you try it in a different order, but the answer will be the same. So we'll solve for x in the second one. Now, if it's x minus y equals 0, that means x has to be equal to y. Okay, and what we're going to do then is take that expression and put it into the equation we didn't already use. So since I've used the second one, I want to put that into the first one. So we're going to take x, put it into number 1. So 2y now plus y is equal to 3. I replaced x with what we said x was. So x was y, so that's why I replaced it. So 3y is equal to 3. That means y is equal to 1. Okay, and I still have to go figure out what x is, because if this is a point of intersection, I need both an x and a y coordinate. Now, I already know that x is equal to y. But if I put this back into some of the other equations, so let's take y, put it into 2. That means x minus y should be 0. But now I know that y was 1. Now I know for sure that x is also 1. So I know I did this correct. And we could verify it, plug it back in, but we'll check it with our calculator. So therefore, 1 comma 1 is the solution. That's the point of intersection. Okay, so we'll show you how to graph that as well. So if you have your graphing calculator handy, you can press y equals in the top corner. I'm going to put these steps in a later example as well for you. So if you forget them, we'll write them down. So y1, you're going to put in the first equation. Now, it has to be in the form y equals, so we need to rearrange this. So this first one is going to rearrange to be negative 2x plus 3. Or you could do 3 minus 2x, it won't matter. So let's actually put it in that way. 3 minus 2x. And then this one, we already rearranged x is equal to y or y equals x. So let's put in y is equal to x. And when we hit graph, excuse me, you're going to see that those two lines intersect. Now, we could use our trace function and kind of draw and see how close we get, but it won't be exact. Okay, so what we're going to do is press second trace to bring up our calculate menu. Now, option 5 is going to allow us to find the intersection. Now, your calculator will ask you 3 questions. First curve, and you're going to see in the top left one of your equations that you've put in. If that's the first equation, press enter. Your calculator will automatically switch to the second line or the second curve. So press enter if it does that. You can always control this by pressing up or down in the cursors, but you want to make sure first curve is one line, second curve is the other line. Press enter. Your calculator will take those 2 lines as long as the cursor is near that intersection, and it'll find out exactly where they cross. And as you can see, that intersection point is 1, 1, just like we said it would be. So we know we did it right. And our calculator allows us to do this very, very quickly. Now, sometimes you won't be allowed to do it very, very quickly with this, and you might have to actually show some of your thinking in your work using an algebraic method, so keep that in mind. So we'll do elimination next. Now, elimination works a little bit differently than substitution. Now, what you're going to want to do is pick a variable that you want to eliminate. Now, it could be x, it could be y, it doesn't matter. But you need the coefficients of them in both equations to have the same number. Doesn't matter if they're positive or negative, but the number should be the same. Now, in order for elimination to truly work, you should have the common, I guess I should say, terms in the same place. So what I mean by that, I want it to look like x, then y, then the constant, or y, then x, then the constant. Whatever you have above and below should be in the same order. You can see our 2 equations are pretty jumbled up. So we're going to put them in order. We're going to rearrange, and we're going to make them x, y constant. So I'll leave the first one as is, and we'll try to put the second one in a form that looks like that. So 3x plus 2y is equal to 3. Now for the one underneath, we need to move the x over to the other side. So let's add 2x. So it'll say 2x now because it was negative 2x. So we're going to add 2x on the right, add 2x on the left. So 2x plus 3y, and our constant stays 7. So now you can see that I have the x's in the same position, y's in the same position, constants in the same position. Now what we're going to do is try to make the coefficients of one of those variables the same as well. Now, as you remember from linear equations, as long as you multiply the entire equation by the same number, the equality stays true. So we're going to try to eliminate x purely by my choice. Doesn't really matter if you pick y, but we're going to multiply our 2 equations by the number to get them both to have the same coefficient. So looking at those coefficients, they're 3 and 2. So I want to try to make them both into a 6. So I'm going to take the first one, multiply by 2, second one, multiply by 3. So we're going to change those and see what happens. So we're going to get 6x plus 4y is equal to 6. Now underneath, we're going to get 6x again plus 9y is equal to 21. Let's just double check before we keep going to make sure that everything's good. So we added 2x over, we got 2x and 3y, that was 7, we're good there. xy 3, xy 3, 3 and 2, okay, so everything looks good. Now we're going to try to actually eliminate one of our variables. So we're going to, since we chose to make the x's the same, now I have 6x in one equation, 6x in the other. If I were to subtract those 2 equations from each other, we're going to notice that 6x minus 6x gives us 0 x's. So this is why it's called elimination, where you're effectively eliminating one of those variables. So 4 minus 9 will give you negative 5y's. And then 6 minus that 21 will give us negative 15. So just making sure that we've got the sign correct and the number correct. I sometimes struggle with the mental math. I mess it up, a real tiny error, but it does make a big difference if we keep using that error. So just make sure that we're on the same page here. So that means y is equal to 3. Now again, just like substitution, I do have to get the x coordinate as well. Now you're free to basically follow the same steps as substitution. Take that y value, plug it back into one of your equations. It doesn't matter which one. So we're going to take y, put it into the first one, purely by choice. So we're going to take y, put it into number 1. So that says 3x plus 2, the y value is now 3, is equal to 3. Now this is effectively 6. So if I subtract 6 on both sides, that means 3x will be equal to negative 3. So x should be equal to negative 1. Okay, and we're going to take these and plug them into our calculator again, show you how to do those graphing steps. So we'll clear those two equations out and we'll make sure if we're right. Now again, it does have to be in y equals form first. So we've got to put it in that slope-intercept form before we can graph it. So the first one, if I subtract my x's, it'll leave me with 2y is equal to negative 3x plus 3, divided by 2 on both. So this means the first one will actually be y equals negative 3 over 2x plus 3 over 2. And that's what we're going to go graph. Now brackets are going to be helpful. So negative 3 over 2x plus 3 over 2. Okay. Second one, we've got to rearrange this. It's already got the y term by itself, so divide everything by 3. This one will become y equals 7 over 3 minus 2 over 3x. You could put the x first if you want. Really makes no difference. So 7 over 3 and then minus 2/3 x. And we'll hit graph. Okay, so there's our first one. And there's our second one coming in. You can see they do cross once. We said it was negative 1, 3. Negative 1, 3 looks pretty good. But we can't just take that as an estimate. Let's go actually double check the exact numbers. So second trace, option 5 is intersect. First curve, second curve, guess. So your calculator automatically switches. So at this point, you could just hit enter 3 times. And you'll find that intersection point. So negative 1, 3, we know we did it perfectly. Okay, so there you go. So this is what we would have done in Math 10. So I've got 2 linear equations, forms a linear system. I've got 1 intersection point at the most. Actually, technically, that's not true. I could have 0, they don't cross at all. I could have 1, or I could have an infinite number of solutions if the 2 lines overlapped. If they were exactly the same, each point on one line would be the same as each point on the other line. So I would have infinite number of intersection points there. Let's go try this one. So it looks a little different because now it's not a linear system anymore. This is quadratic because you can see that exponent of 2 above our x. Now, if we remember how to graph those by hand, we could absolutely do that. And then we know how to graph the second one because that's linear. So let's talk about equation 1 first. Since it's a quadratic, we need to find a couple of points. We need a y-intercept, some x-intercepts in order to graph this. Now remember that the constant is going to tell you your y-intercept, because if you let x equal 0, that means y is equal to 8. So I know that my y-intercept is going to be 8. Now I've got to find some x-intercepts to tell me where I'm going. So I know if that's my y-intercept, the negative sign tells me I open downwards. So I know I'm coming this way. I just need to know where I'm going to cross in order to have the right shape. Now, if I let y equal to 0, the reason I'm doing that is if y is 0, that will give me my points down on that x-axis because on that line y is 0. So what we're really doing is trying to find the zeros here, the x-intercepts, the solutions, the roots, whatever you want to call it. So if I move the 8 to the other side, that'll give me negative 8 is negative 2x squared. Divide both sides by negative 2. So positive 4 is equal to x squared. Now you can take the square root of both of those to get positive negative 2 is equal to x. So there's your zeros. So x, when x is positive 2 or negative 2, the y is equal to 0. So one of your x-intercepts is on 2, the other negative 2. And now we've got enough information to draw that shape. So as best you can, make that parabola shape. Doesn't have to be perfect because we're going to use the calculator here. So if it's a graphical method and you're doing it by hand, it'll be very, very tough to get perfect. unless you graph or unless you find, using a table of values, a bunch of points, it won't be super exact. So we'll do the second one as well. Now all we need to remember is to put that into y equals mx plus b slope-intercept form, and we can graph it very easily. So let's rearrange this. I need y by itself, so let's add y to both sides, and we will add 3 to both sides. That will give us 3x plus 3 is equal to y. So that means 3 is my slope, and my y-intercept b is also 3. So we can plot that very easily. Our y-intercept 3. Now the slope is 3, so we're going to go 3 units up, 1 unit over. Rise over run. So if my slope is 3, that means my rise is 3, and the run is 1. So 3 divided by 1 gives me that 3. So up 3, right 1. 1, 2, 3, and 1. And you can see we're going to cross that parabola up here. Now I could keep going. 1, 2, 3, and 1 more, and I can effectively see my line. But by drawing it, you can also see that I should have a second intersection point here, somewhere in this area. Now again, with drawing the graph by hand, I don't exactly know for sure what it is. I do know that I'm going to have 2. All of the other ones only had 1 intersection point, but we need to make sure we find both. So we're going to go do that in our calculator. So y equals, take out anything if it's already there. And again, we have to enter these in y equals format. So let's put in the first one. So negative 2x squared. That's a plus 8. And the second one we already rearranged. So 3x plus 3. And we'll, okay. Sometimes you have to change your window settings because by standard it only goes 10 by 10. So here we look good, same exact picture. So let's go find those intersection points. So second trace, option 5 is calculate. Now we've got 2, so we've got to move our cursor close to one of them. And again, the same steps happen as before. So hit enter 3 times. Your calculator takes that information and finds one of them for you. So 1, 6, pretty much bang on to where we graphed it. So let's go label this. So intersection points. Okay, one of them is at 1, 6, and I can see that there's a second one. So we've got to go do those steps again. So second trace, option 5. Now, if I just keep hitting enter here, I'm going to find the same one. So I've got to actually move the cursor closer to the other one. Doesn't really matter where you are as long as you're in the general area. Then you can hit enter 3 times, and your calculator will take care of the rest. So your other point is negative 2.5. and negative 4.5. So with it being that decimal, our graph wasn't really perfect because of the way we've drawn it, but we are in the general area. It should actually be a little bit lower, but that's all right. So we've got the general shape, we've got the 2 points, we're okay. Now, sometimes you actually find a system where you don't have a solution. So even if you tried it algebraically and you tried and you can't figure out why it's not working, sometimes the lines just don't end up crossing, and that's okay. So if we go to graph this one, we can try doing this one by hand first. So the first one, it gives me the x-coordinate of the vertex is 3. 0 is the y-coordinate of the vertex because there really isn't anything on the end. So 3, 0 is going to be my vertex. Now, I can figure out what the y-intercept is going to be by letting x equal 0. So if x is 0, 0 minus 3 is negative 3. Square it, and I get positive 9. So I know I'm going all the way to up here. So I know my parabola is going to look something like this. Now, we can try to factor the second one to give us some x-intercepts. We can let x equal 0 to give us our y-intercept of negative 9. So I know my y-intercept is going to be right about here. Now, by looking at that leading coefficient, if it's negative 3, that means my parabola actually opens downwards. Now, looking at this picture, I know for a fact that these two are never going to cross. There's no intersection points here. So that means there's no solution. No matter what you try doing algebraically or graphically, these two will never cross. And that's okay. You might not have a solution. So all you need to say is there's no solution there. For the other two, we're going to try doing them graphically as well. So let's clear out everything that was in there and enter them in exactly how you see them. You don't really have to rearrange them. As long as they're in that y equals format, we're good. So 3x squared is the first one, minus 3x minus 8, and then 12 minus 3x minus 2x squared. And we'll hit graph. Okay, so I got 1 on there, and there's the second one, but I don't really see the vertex, and I'd like to. So we've got to change some window settings. So if I press the window button, I can see what my scales are for my grid. So I know my problem was up here. It didn't go high enough in the y direction. So we need to change the y maximum. It's currently 10. Let's make it 20, just to see. I should still see everything else. And there you go. Now I see a better picture. So there's 2 intersection points here. They cross twice. So we're going to go do the same steps. So we will write those steps down. Let's move that. So step 1. Enter the equations into y1 and y2. Okay, and they have to be in y equals form when you go to enter them. Step 2, you can hit graph. Once you do that, you get to our picture like it looks here. And then we're going to press second, trace, intersect. Or you can just press second, trace. You can go by the numbers as well, so you can press 5. Okay. And then we're going to put the cursor near one intersection point. So step 3, place cursor near intersection, enter 3 times. So once you're close to it, hit enter 3 times, and there's one of your intersection points. So here it could either be 2, -2, or now we'll do step 4, repeat steps 1 through 3. So you can do this for however many intersection points you have. Since we've got 2, we have to do all those steps just one more time. So second, trace 5. Let's move closer to the other one. And again, enter, enter, enter. And there's your other one, -2, 10. Okay, there's your 2 intersection points. Let's try this other one. So y equals, clear out everything. X squared plus 4x minus 12. Underneath, 2x squared. That's a -10 and a plus 12. You can combine those, and it will be plus 2. I'll hit graph. Okay, so there's the first one. There's the second one. So right now, it really doesn't look like they cross at all. So let's try to see what happens a little bit further up here. So let's change our window settings again. We're at 20. Let's go big. Let's go to 100. Okay, I know I don't really need the vertexes of either of them, but look at the shape here. These two are pretty much diverging from each other. So the one above is going to keep going straight up this way, and the other one's going to keep spreading out a little bit flatter. So by the looks of this, they're not going to cross at all. And again, that's okay. There's no solution here. There's no intersection point between those two parabolas. Okay, so the number of solutions in a system can be represented in multiple situations, both including quadratic linear systems and quadratic systems. So we just graphed a quad system, 2 quadratic equations. We did quadratic linear before when we saw 2 intersection points. So this is just a helpful diagram to explain some of those intersection points. So you could have no solutions that don't cross at all. One solution, the line is basically tangent to that parabola, so it touches it only one place, or it could cross twice. It could go right through it. Now, solution of a quadratic system could have a couple other scenarios. So it could be 0, could just have one. So basically the vertexes is what you're looking, the vertices is what you'd be looking for there. It could have two solutions so that they intersect each other twice, or it could be infinite again, so they could perfectly overlap. Okay, just like in Math 10. So just a little bit of extra stuff to think about because of all the stuff that comes with parabolas, but not a whole lot more than what we did before. So this was how you would do it graphically. So the next time we see each other, we'll do this algebraically and see how those methods of substitution, elimination, how they change a little bit when we do this using algebra. So again, please make sure you're asking for that help when you need it, and we'll see you next time.